Hi guys, well I've been promising this video for a while. I finally managed to get around to doing it. So we're going to have a quick look at the way that FTTC, Fibre to the Cabinet, BT Infinity or whatever millions of other brand names refer to it, and how it all works. So it is in essence a bodge. It's a get round to the fact that the telephone lines are not really capable of supporting the data we want. So what we do is we move the actual transmission of high-speed data further out into the network. So we've got this here is a fairly good approximation of the telco's equipment, which is this and this unit here, which we'll look at, and then your own equipment in the house, which are the phone lines, the modem. I've got a router over here as well. So this is mostly applicable to the United Kingdom. I believe similar systems are used in North America and sort of US and Canada. I'm aware in the US and Canada that some of them actually mount the DSLAM, which is this thing, actually up in a pole. They have a device with the combiner and everything all split in, so literally your incoming phone line goes into the box, the outgoing phone line incoming phone line comes into the box, outgoing phone line goes out. There's nothing else to it, it's line powered. But this is mainly UK based. So technical name for this is FTTC, or Fibre to the Cabinet, which is different to Fibre to the Premises, FTTP, or ADSL. To most extent is DSL, although this is a subset of DSL. So ADSL and DSL in the UK are normally delivered from the telephone exchange. This unit here, the DSLAM, lives in the telephone exchange, and obviously that does have an effect on the speed of the line and the reach. Not many people live within a reasonable reach of the telephone exchange. So what's going on here? Well, the idea with FTTC is that, as I've already said, we're moving the data transmission and reception equipment further out into the network. What we do is most of the cabinets in the network will have a DSLAM placed in the cabinet. What I will do is, bear with me. So excuse my mug, but this is where the magic happens. This device normally lives in the green cabinet's side of the road. This is a Huawei Smart AX DSLAM. This is similar to the kit that BT use. There are some subtle differences, which are down to we use different cards. We use vectoring. BT decided that having tested it, they weren't going to go the vectoring route. So the fibre to the cabinet part comes from here. This is our incoming data. This would be what's called a gigabit passive optical network, or GPON connection. In our case, it's just standard Ethernet over there. You have two ports. These ports are capable of gigabit, so one of these DSLAMs tops out at 2 gig. So this is why some contention issues happen, why there is a physical limit to the number of customers that can connect. I'm connected, or this modem is currently connected at 70 meg. That's what I've set the profile for on this, and then the black box at the bottom is in charge of power. That black box would be connected to environmental sensors, to the box alarm system, and we've got battery outputs down there as well. So the idea is these are designed to go into the Huawei cabinets. They are the most common cabinet that BT run, and the entire system is sold as one unit to BT. So the cabinet, the distribution frames, the environmental monitoring, the battery, everything comes to BT in one lump, and they just dump it in the road. So we'll go back to the other camera now. So the idea is that we need to insert the DSLAM into the phone lines, and the way this is generally done is, you'll already have seen long before we went down the route of FTTC or VDSL, which is what this is. You'd have been familiar with the green post office telecoms or BT cabinets that were in the road long before we started. And what generally happens with them is this kind of arrangement here. So you have your large trunk cable coming in. This comes into a distribution frame, which is vastly cut down by here. You have another block here which goes out to all the phone lines to the customers, and your engineer comes out and connects one of these lines to one of those, which connects your phone line, and everything is good. You've got a phone line. The extra step that happens with VDSL is we're now patching to the output to the DSLAM. This is slightly different. This arrangement isn't present in the green cabinets, so this goes off into the DSLAM, comes back via a combiner, which is this here, and the combiner is how we inject VDSL signal onto the phone line. That comes back from the DSLAM, and then we jumper that over to our phone line, and off it comes down to the junction box on the side of our house, if you're lucky enough to have one that's in this good condition, and out to our telephone network. This is why a lot of people are now saying that I've phoned to BT, I phoned Sky, I phoned so and so, and they said, well, there's no capacity in the cabinet. That's because there is a finite capacity in this, as I've already explained to you. There's only 2 gigs of connectivity on here. You can upgrade these. You can put extra cards in them to provide more connectivity, but you're also limited by the amount of fibre that's available as well. If you've got, we've got 32, 64, we've got 48 channels in this box. If each one of those is pulling 70 megs, then you're going to have a problem with congestion fairly quickly. You can, in theory, put 64 channels in here, and you can even go further than that. And this unit also supports optical interconnects and Ethernet supports optical interconnects and Ethernet interconnects, which are capable of gig as well. So very quickly you're going to run out of bandwidth, and this is when you're being told that there is no space in the cabinet. It means there is no space here to patch you into because there's no ports available on the DSLAM, or there's physically no traffic or no bandwidth left to patch you into. So we come back and then we go down your telephone line. If you're really lucky, it will be nice, good high quality telephone like this. Unfortunately, in a lot of the UK, it's going to be twin pair copper, which isn't going to do you much good. So I'm going to go all the way back to the modem and explain how we get there, because there's a lot of problems you can have with this can impact your speed as well. But essentially what we're doing is we're taking the incoming phone signal, sending it off to the DSLAM, as I said here, superimposing the DSLAM signal. This is a really crap combiner. No one would use these. We don't even use these. It's just the easiest way I can do this demonstration. Coming back from the combiner, you now have on this block your telephone signal and your VDSL signal, and then this goes out to your phone line, and I can demonstrate that. This phone is plugged in here. Incidentally, this number is available for use on the BT network as well. It's a handy one to know. That's 17070. Our phone system is being a bit slow today.
Thank you for calling the engineering test number. If you're unaware of how to use this number, please hang up now.
I would say this is a fairly good model of a standard telephone system. I think it's a phone. So for example, if I dial another number,
your call cannot be completed as dialed. Please check.
Okay. Not quite sure why we did that. Let's try that again. There you go. So this is a standard BT analog phone, the kind that anyone can buy. We're providing our phone lines for another piece of kit on the other side of the room. That's what you could hear ringing over the other side. It's the test phone on our FXO. I can never get FXO, FXS right. But yeah, we've got 24 phone lines coming in on this here. So that's how that works. So the next thing is how all of this goes together. So this is an ideal installation. This is a perfect installation. This is done exactly the way that BT said it should be, and doesn't include some of the lovely details such as the 1970s GPO junction boxes instead of these, which have been left like that and are now full of spiders, or the million joints and random jelly connectors that are in here. The jelly connectors are a fairly new-ish advent to telephone lines. Before that they used the little blue crimp connectors, which you would frequently have seen large numbers of littered on the floor around the distribution frames. So yeah, ideally what happens is your line comes in. We've got this set up as two separate lines coming in. So we've got one line here without any VDSL. This is just a straight phone line, and then one here with, just to show you how it all goes together. In this grey box you will find jelly connectors, which are these. Incidentally, you shouldn't be touching any of this. The only bits you can touch start from the test connector on here, which will go on. But it's good to be able to have a look in here, dig out all the spider eggs and say, right, okay, this is the problem we've got here. So we've got our black line coming in here. We've got two phone lines coming in here. So we've got one on the orange pair, one on the blue pair. As you can possibly see over here, we've got these two punched in over here. Can't really see the orange, but the orange is the first one. And this is generally how multiple phone lines will come across. So one pair per phone line comes in, and then that goes out to your master socket. If we go with the old crusty master socket here first, we've got 4 different types of master socket here. This is where your phone line comes in and where everything should be connected to. Now again, unless you have one of the newer NTE 5-star sockets, you shouldn't be taking any of these apart. This is down to BT. I would possibly say you could get away with as much as taking it off the wall to decorate, but you really shouldn't be changing things or indeed wiring to this. If you're doing extensions, you're not allowed to wire to these. So this is one of the older type BT sockets, and as you can see in here, we're just on pins 2 and 5, and that is literally our pair from here. A couple of other examples of master sockets. We have this one here, which is quite similar to this one. The master sockets you can tell because you've got a handful of components in here in the large ring cap. We've got a slightly newer, I believe this is an NTE5 here. So you've got an earth, your A and B terminals, which equate to 5 and 3, and then everything is covered over. You can't get to anything in here except for those terminals. And then there's your familiar test socket, and you'd have your faceplate on here. And then we've got a much older one here. Same thing again, but you can see instead of the little black silicon surge arrestor you've got down there, we've got a gas discharge tube in here. So there's 4 different types of master socket, and obviously we've got the NTE5C Mark IV here as well. If you're wiring extensions to these, then the way you do it is with one of those multi-adapter type things that plugs in the front, and then you wire your extension to that. There is something to be aware of when you're doing those, which I'll touch when we go into this one in a minute. I'm not screw that all the way down. So this is the NTE5C that you'll all be familiar with, or should be. If you're using VDSL, you should have one of these. It is possible to use VDSL with a standard microfilter like this. There is no difference between an ADSL and a VDSL microfilter. They are exactly the same, and there is nothing to stop you from going like that and using your VDSL like that. In this case that isn't going to work because the way the microfilter in here goes together would stop that from working. Actually it might work because I can't remember how I wired that in. We'll see if that gets a light while we're working. Have a bit of coffee. Yum, cold coffee. Right. This is a Mark IV. There is, I believe, a Mark V, and there's previous versions of it. All they're pretty much for muchness. And certainly in newer houses, this is what you'll have. If you've had a BT engineer out to do a broadband installation, then you'll have one of these as well, and you can sort of argue for BT to come and do them. So there's two parts to this rather than the usual single part, much like these, and in fact that should fit on here. So if we take the phone line out and then you squeeze on the side and unclip it, and that should, no it doesn't. So yeah, that doesn't work. There's something else. So if we take the front off, you can see we've got some different connections in here. So we've got this here. This provides a filtered connection out to your extension. So if you wire your extensions into here, you don't need microfilters, but it does mean your modem's not going to work anywhere else. And then you've got your conventional extension connections here, which is 5.3. I can't remember. It's 5.3 and 2. Yes. Now you'll see that we've got, this is a common cause of problems on noisy lines. So you see we've got 3 connections here to our extension, and the orange one is what's called a ring wire. It was needed many years ago on much heavier consuming telephone devices, things that had electromagnetic ringers and things like that in. It's no longer needed, but it can act as an antenna. So generally you want to wire extensions with the 2 wires and leave out the ring wire, which is this orange one. If you've got VDSL and you're using it from an extension, then it's worth seeing if that ring wire is present and taking it out and seeing if that helps. This is also filtered, so there's no microfilter needed up here, and as you can see we've got no DSL connection there at the moment. If we move this over here, that will come up. If you're having problems with your phone and DSL, this is your first stop. Plug in here, because the act of removing this face cover isolates this, and you are now plugged straight into the phone line. So any extensions, any other problems you've got will no longer be in play. And you can see that we've got a DSL light here. That should eventually stop flashing and connect. There we go. We should see some traffic. No, we won't, because I've not got a network plugged into it. No. Let's plug a network into it just so we can get some traffic. There we go. Nah, that's not going to work properly. There's something wrong with that network cable that I've been chasing for a few days. Or something wrong with that port on our switch downstairs. So yeah, so at this point you're isolated from everything. You would need to use a microfilter to plug your modem in, but if your problem goes away when you do that, then it's going to be something with your extension wiring that's causing the problems. If I plug that back in, oh, let's just have a look in here. It's not really any different to, let's just grab a better tool for the job, i.e. the right screwdriver. It's unusual, yeah, for excuse of wobbling, for these sockets to have the brass inserts in, which means getting the screws in and out of them can be a bit of a pain. They are literally just self-tappers, whereas if you've done any work on UK electrical systems, you're used to the lovely brass inserts and the fact that things generally just go in the way they should do. Obviously we've got an extension wired into this one, which is what these are, but you'll see again we've got the single pair, and we're A and B now rather than what we were 3 and 5 in there. But we do still provide that orange wire, which looking at it is in the wrong place. No, it's not, it's in the right place. Just put that back on. You do need to put the screws back in these, otherwise the faceplate will not go back on. Again, this is what you should ideally have and be connecting to, but it really depends on how old your house is, how old the wiring is, and whether you can convince BT to install one. Certainly it makes life a little easier because you've not got microfilters all over the place. I'm pretty sure that output on there is filtered, so I'm just going to plug the modem in to see if that connects. It shouldn't do. Obviously if you do things that way, then it means that you're not going to be able to put your modem somewhere else in the house. No, we are syncing up. No, we're not syncing up. Okay. So there we go. I mean, there's not a lot to it. You are free to touch anything after the master socket. That's not a problem. You can mess around with that to your heart's desire. But anything up to that master socket is BT's, and you shouldn't touch it. I would argue that if you want to pop the cover off of this to give a visual inspection, then that's fine. Generally, as I've said several times, these are completely full of spiders. You may find other things in them. If you're a Virgin customer, quite often you'll find the quite large box that they use just hanging off the wall, which isn't ideal, but it's a source of problems. There's also quite often you'll find setups like this, which will just be a mass of cables with jelly crimps in on the side of, say for example, if you've got a terrace, you may find a junction box on the side of the terrace that will contain an incoming trunk like this, a load of jelly crimps, and then the individual lines. BT do, or some of the, I'm not saying every engineer, but it's quite frequent that you'll find that the lids on these are not put on correctly, they're left loose, or they're just not sealed properly. Water will get in, especially if there's the older style blueprints in there. The water gets in, and that's why you quite often have problems with ADSL dropping, or ADSL and VDSL dropping when it rains, and problems with call quality as well. And then the other end, once it gets to your house, the next step would be to go through either a modem like this. We use a lot of these modems. These are the Huawei modems. We've got a Huawei DSLAM, so we use Huawei modems. We've also got custom firmware for these, so we can reprogram them. This is designed for use with a router or a firewall, so there is no smarts in this at all, or that you need to worry about. There's no smarts in here at all. And then generally you'll plug a firewall router type thing in there, or some suppliers will provide their own equipment which includes both. There's a fairly good example there. That's the Skybox, the SkyQ hub. Completely useless for anything other than Sky, so that is junk. And there's it's one of the older BT ones. Again, this is an all-in-one. You plug your broadband in, plug your DSL in, and that's it. These quite often come with 4G sticks on the BT service now, so they've got a failover type setup on. Incidentally, these ones, if you've got one of these kicking around, these can be quite easily made to run other software. And you can just see in the bottom there are 4 pins. That's to allow us to reprogram these with other software. The BT software is pretty crap, it's not that good, but same with the Skybox, they're locked down, they're not designed for people that are going to play, want to play and do impressive things with them. The other one we use quite a lot of the Dratec Vigors, which include the modem as well. But generally if we're doing large installs, we're going to use a firewall, which means we just use a dumb modem with it. So yeah, that's about it. That's all there is to it. It's just a break into the phone line. That's what the green cabinets are for. You'll find them next to existing BT distribution frames, and literally it will be your trunk in, your phone lines out, and there'll be another cable similar to this that goes under and into the new BT cabinet for the VDSL. And I'd say that really is about it. If there's anything that you want me to go into more detail in and sort of explain a bit more, then please let me know. This is just a very, very quick run through, but there's not much to it. It was designed to be simple. It was designed to be a quick fix to the lack of broadband, and it is. I mean, it's fairly straightforward. You're just breaking into the phone line and popping another signal on top. The fibre that everyone references to, and this is something that I personally have a big problem to, is the fibre offshot here, this fibre here, hence fibre to the cabinet, but your connection to the cabinet is still copper wires. It's still old-fashioned copper pairs, if you're lucky, because it could be CCA or plain aluminium. Areas that have a lot of aluminium phone cable, you generally aren't going to get broadband through, or any decent broadband through it. We've got customers that live within, well, we've got one customer who's on an industrial estate, and then at the entrance to that industrial estate we've got another customer. The customer at the entrance is actually on G-Fast. They are receiving 300 meg down VDSL. The customer that's just a little bit further in the industrial estate is receiving 4 meg. And the reasoning for that is the aluminium phone lines that are used are just too low quality. They have constant problems with ISDN. Yeah, it's the luck of the draw, unfortunately, with that. But yeah, I can't think of anything else to add to this, so if there's anything else you want to see or anything you want more detail on, let me know. This is our training rig. As I say, we use this on event sites and things like that, so we use this to train our staff and get them to make determinations. That is a different situation to someone at home adding to their telephone network, where we're responsible for all of this, the same as the BT engineers were, and occasionally we've had BT use our infrastructure on show sites as well to bring phone lines in. So, you know, we go a little bit further. But yeah, anything else you want to know, please feel free to ask.